So I start just with a few brief reminder on the chronology of the building and its exceptional dimensions. So the construction of Notre-Dame in its Gothic form, as we know it nowadays, started in the 1160s under the bishopry of Maurice de Sully, who is the bishop who really started the construction, and it lasted till the middle of the 13th century. We'll go step by step afterwards on several construction spots. Also to know that there was a strong restoration in the 19th century by Eugène Viollet-le-Duc, notably in the upper parts. He made the part of the framework and the roof, and he made a new spire. And that, all you know, there was this gigantic fire in April 2019. Just to recall that at the time it was built, Notre-Dame was the highest Gothic church ever built at that time. So it's the first time that the vaults of a Gothic church peaked at more than 30 meters, that's 33 meters approximately. Also quite a long building. So we go back on these questions. So just this reminder, and now I'm going to speak of what happened in 2019, how the research organized itself, and I'll go briefly then to results of different working groups. So, well, you all know that the 15th of April 2019, there was this fire that took place in the spire of Notre-Dame, and in the days that followed the disaster, then the researchers started to organize. First, researchers on their own, they gathered and they met and they just said that they want to do something out of it, and really quickly the National Research Center for France, CNRS, and also the Ministry of Culture, they organized and funded this program that is still lasting today and will last till the end of next year. There will be a great symposium in April 2024 organized in France with the results of some of the results of the scientific program. So it all started really quickly. And what happened, so that's about 50 labs, about 200 researchers that were that gathered and that were organized by the CNRS and the Ministry of Culture, because there was this idea that despite the destruction, these archives, whether they're material or wood, stone, etc., or metal, or immaterial, because there's the sound of Notre-Dame, for example, that was lost because of the fire. That's also the spirit, what people think about what happened and compared to other fires in history. Well, that there was matter to save and to study. And so they organized a multidisciplinary approach arranged in 9 work groups. I'll speak about this just afterwards. And the idea was first for some of the work group to accompany the architects for the restorations, to help them to understand some points where they did not have the skills, or the scientists had better skills than the architects to know some things. And then also to, notably for the choice of material reuse for the study of some alteration from fire, but also to have a broader scientific program that would last till the end of the restoration, and even after the restorations, we will see that some projects there will still continue at the end of next year when Notre-Dame is going to be. So a really big program applied to restoration, and also for the knowledge of the monuments and much more that was organized. To see materially how it went, so that there you have images of how Notre-Dame looked in the inside just after the fire. And so the problem was how to study this, because you see it's a huge pile heap of nothing. And so what happened is that really quickly the Ministry of Culture, the archaeological services, they decided that this was not rubble, but these were archaeological remains. So they decided to excavate this as if not really, but as if it was an archaeological excavation. So despite the problems of the most dangerous, people could not go there in the middle of Notre-Dame. It was only robots who could go there. There was the lead problem also. So it was really difficult, but they decided to make some photographs from the top and to make a grid, an archaeological grid, so to know which material was sampled where, was recovered where, to try to understand where it came from. Because it's obvious that if you're in the nave, you will not have a stone from the floor or something like this. Well, the spire went a bit like this, so it made, for some elements, it made it a bit more difficult, but that was the idea. Staying on the top, you see the grid that was made, the woods that were pre-identified before they were set down, and then for the rest, all the remains in the charcoal, they had to be sorted. Charcoal was taken out for some parts, all the real rubble was taken out, but all the artifacts were collected according to the grid. So that's, you see us working here in 2020-21. So that was for one thing, and then which is unprecedented in the history of cathedral to have such working after a disaster. And then what happened, thanks to restoration, the monument was entirely scaffolded. Not at first, but then at first we could access places that could never be accessed, like here on the top walls. You see me working, they're walking there, which is normally you cannot do that. So to access places inaccessible, and then you have access to the entire monuments thanks to the scaffolding since last year, only since 2022, when the restoration really started. So that's really important to have this, to be able to scan the monument entirely. So that's how some researchers could be developed. And so there's many archaeological materials that were taken down because they were burnt or because they were restorated, such as this iron print that you see on the top right, and that are available to study, because some materials are reused in the construction, but you can guess that the burnt timbers, they're not reused in the construction. So that's real, entirely archaeological material to be studied, and we'll see in a bit what we can study about this. I was speaking of the 9 work groups, and I detailed some thematics afterwards, especially for the material work groups. So there were 4 main materials: stone, metal, wood, glass. Also specialists of civil engineering who made a structural work group and who really helped the architects to know the movements of the monuments and things like this. Also on decor, on acoustics, and some anthropologists working on heritage and other things, and think about the remains, archaeological remains and restorations. And also a digital work group who gathers the information of everybody and will make them available for the larger public. So we've been working more or less since, let's say, January or current 2020, when research started to be funded, and that we also access inside not least first. So now get a bit more in detail about some results of the stone and wood groups and the research they're carrying out, and afterwards I speak of what I'm carrying out in the metal work group, which I am. So one discovery about Notre-Dame was the way the cathedral was built, and especially I was speaking of the 33 meters high vaults, that for the first time we had a confirmation of how slender and thin the structure was. it was really easy to measure the size of the wall, the thickness of the walls, because it was pierced in several places, bigger than in the normal monuments. And so the researchers, they could see that it's about 15 to 20 centimeters thick, which is really, really nothing compared to what we know for other monuments, just such like in Sens, which is a bit earlier, or Chartres, which is a bit later, which are much, much thicker. So that's the important information about how the architects, they try to make the slenderest, thinnest structure possible. For the first time, they built vaults peaking at more than 30 meters high. You could imagine that there was some fear maybe to have a structure that was too heavy and that could not be sustained by the walls. And the size of the walls on the top is also really, really thin, because it's only 60 centimeters thick. So imagine it's not that much when it's peaking at 30 meters high. The other question was on the flying buttresses, and it is said sometimes that that's in the core of Notre-Dame, that this kind of flying buttress was invented, and it has been proved that they're really the original ones, despite the fact that they were made partly in the 19th century. And to better understand the role of these flying buttresses, and that the fact that sometimes it's been written on other buildings that you see here, you see my arrow, that the vault is here, and that there's the impression that the vault and the forces of the vault will go this way on this point, and that the flying buttress might be located a little bit too high regarding the way the vaults are built. And the destructions that occurred because of the spire here and here, they showed in real that there's no need for the flying buttress to be so low, because all the first part of the arch really, even if it's still the arch and the vault, it actually structurally belongs to the vault, and it did not fail when the vault fell. It will stay, and it stayed with the vault. So that the architects of Notre-Dame, they really found right place to set the flying buttresses, although it was one of the first flying buttresses ever built in as we know so far. And there's much more work that is being carried out at present, because actually we do not really know how this gigantic Gothic churches were truly built and how they managed to reach such height. I mean, we can see how it works, but then there's research that is currently being funded from the wood and stone and structural work group, and to understand and to compare Notre-Dame with other big churches which are contemporary. It's just starting now to have more resources. Also about the other questions about the type of stone that was used in Notre-Dame. So there were already some analyses that were made during restorations in the 1980s, but now, as you see, the monument could be scanned really in the whole way, and it could be proved that, so it's a general picture I'm placing here. It's not the case everywhere in the monument, but usually, and especially in the later parts in the nave, you can see that different kinds of limestone. It's only limestone which is used from the Parisian basin, which is extracted in Paris or really nearby. That there are different kinds of stone, and that, for example, for the arches, which need to be which have to be finely cut.
Somos muitos.
Okay. We already saw mine. Okay, thanks. what was I saying? That the arches that need to be really finely cut, well, they're made of harder stone and heavier stone, so that's last limestone on the better banks of stone, and that the bolts, they're made of lighter stone, which is less resistant, but also much lighter, and so it helps to lighten the overall structure. And that for all the decorations, for the traceries, for the really slender columns, which are like 4 meters high and only 15 centimeters thick, they're made of the hardest and finest stone, which is called the Université de Paris, which is really, really thin bank, but which was used at that time to make such sculpture. So real adaptation of uses between lightness and hardness of the stone. But that sometimes, on some places, and here you can see the inside of the core of the top walls and the inside of the nave of the top walls, and that, well, at 2 different times, because here we're roughly maybe partly in the late 12th century and here in the beginning of the 13th century, that we have different kinds of work. You see here, there's reuse and that it's not really homogeneous on the first part, whereas on here it's really homogeneous. So that there might be periods where, despite what I just said before, well, they needed to, or they had at their disposal stone that could be reused, and they did that, even though we're in a really rich building yard. Reuse is an important thing when you can have it. So in some places in the construction, that was really could be proven for the first time in the open parts of the landscape. Another thing, for example, is that first time that the masons mark. So I'm saying masons, it's not really masons because it's not all the time single mark from a single person, but it could be studied throughout the cathedral thanks to the scaffolding. I'm giving here an example from St. Louis in the stonework rock that scanned the tributes and showed that the kinds of spines, they're really different from the north and south, which means that 2 different teams work there, 2 different groups of workers, of stone cutters, and that there's also a difference between the first base and on the west and the others on the east. You can see this bar break here between the bars on both sides, which means that there are breaks in construction, and also to better analyze these signs, that they sometimes are identical but carved in different ways, different tools. So it means it's not a mason mark, but rather a workshop mark, or to identify the stone. So better knowledge about the chronology of the cathedral that will match with the results on other materials such as wood, also for the upper parts, and metals as we can see. About the wood, so there could be a thorough study. There were already some studies in the 1990s, but there's a thorough study of the current timbers that is being carried out. So now, what we know that the timbers, they're all made of oak, which is really normal for a framework at that time, and that most of them are, let's say, young oaks, which are about between, say, 50 and 100 years, not more than 100 years. And that they were specifically selected for their size, which is quite thin, actually, because 30 centimeters is not that thick for a tree, and the length, because we needed to have 12 meters length to span the main vessel, the main nave of Notre-Dame. So that about that's the dendrochronology that we take this information, and also that it means that one framework, which is about 1,000 trees, is only 3 or 4 hectares of forest. So it's not that much. It's been said that to rebuild Notre-Dame at the beginning, we would need to lots of lands and forests to have the necessary trees, really old ones, but that's not the case. That's not how it works. And there's also, for the first time, the evidence that thanks to these small dowels that are filling a hole in some of the timbers. These were the holes that were made to tie the timbers together when they were sent on the river for supply. So that some of these timbers, they were brought to Paris by river, by floating. And now the question is, where did they come from? So there's in the timbers, in the burnt ones, there's still much information about the geographic origin, about the climate in which the wood, the trees did grow, thanks to certain elements or say certain isotopes. I'm not going to enter the details, but one of the work of the woodwork group and one PhD that is going to be defended soon was about to determine the provenance of the woods regarding where the chapter and where the bishop had their domains, regarding the basin of the Seine, because now we know that some of it comes by floating, and regarding also the type of trees that are bred in these regions. And you see, we were looking for really slender trees like this that could come from some kind of forestry made rather by coppice to have this kind of trees, so that the trees would not grow too thick, which is what I said before, because one tree is actually one timber. You do not sow it in the middle. Take one tree, just slice the outer part, and one tree make one timber. So they're presently working on these questions, and also one thing which is going to be really interesting is to reconstruct the climate of the 12th century. As you might know, 12th century was an optimum, really hot period after colder period until the 10th century, and before another cold period in the 14th century. But it was a natural hot period of optimum climate, not as now, which is also a natural optimum climate, but mainly also mainly due global warming. So the results on the 12th century, they might be also compared to what's going on now, to rather share evaluate the shares of what's the real climate, optimum climate in a natural way, such like in the Middle Ages. And also, well, one of the questions in Notre-Dame is a question about chronology, as I said before, about stone. And we now know that we knew almost nothing about the chronology of Notre-Dame, and much of it is going to be renewed, not the beginning and the end, of course, but more precisely in the middle. And for example, with the framework, we now know, we knew that there was a first framework in the end of the 12th century that was dismantled, and that was then rearranged again in the core. But it seems that it was first, there was the framework of the nave, which was built in the years about 1215. And at first, we believed that the nave was built after the core was rebuilt. And now we know it's the other way around. So it seems that carpentry the work started here in the 12th century, and then it started in this way in the 13th century, and then the core was remade after the nave was entirely built. So we have new information about this, and the people are still working on it. There are faces which are not shown here, but in the late 13th century, which seems to be that there was already some really heavy repairs at that time that were not known so far. So there's a really precise chronology that is going to be rich thanks to the results. So now I'm going on to the question of the metals, which I'm rather myself working on. So I'll try to, if I'm not too long, I'll speak about iron and lead. If I'm way too long, then I'll just speak about iron. And just to tell you that you've understood that for stone and wood, there were many discoveries, and so was it for iron. About iron, we knew almost nothing about Notre-Dame. We did not know that iron was used in its structure since the 12th century, that it was maybe the oldest Gothic church to have used this iron trunks as a construction material. And so some iron trunks, they appear, you see, that's the wall where the framework was. So without burning the framework or restoring it heavily, we could not have seen these reinforcements. And also many pieces that were found inside. About lead, well, we knew that lead was employed, but I go back to this further because it was the opportunity to lead some programs on lead, although most of it was destroyed during the famine. So about the group, and I'd like to insist on the fact that the presentation I'm making is not a single work of a single person, but the work of about 50 people that work on different thematics, from environmental chemistry to archaeology, history, and material science, and which are all involved in this project and working with their different skills to better understand the way these materials were used and what we can, how we can study them to better know the construction and not from them, and also other things. So I start with the researches on iron, and so as you can see, there's multiple questions that arise when it comes to iron in our architectures. First, to know where it was used and in which periods does it belong to construction, does it belong to repairs, to investigate also the quality of these alloys, notably for reuse. That was questioned by the architects, but also more broadly to compare Notre-Dame with other monuments. The question of dating, which is important to understand if it was from the first construction or not. Then, knowing all this, to try to evaluate the role played by some parts of the metalwork, and to investigate also the questions of supply of the building yard with the question of reuse, which is important for stone, for wood, but also for metal. And about this, we had first part of study on some samples, and that's what I will speak about. But I like to stress on the fact that there's a PhD under my supervision and other colleagues that started last year. And so that's been following the last parts of restoration. I will speak a bit about this later. And so that will bring much more information, much more iron elements analyzed than what I'm going to show now. And so that's just started and finished about 2 days. So first, about the uses of iron. We're trying to go over the Notre-Dame structures, and what struck us at first was the importance of iron trunks in the structures, which are built like you see here, kind of big staples that attach the stones together. So we only knew the ones on top here because of Viollet-le-Duc's drawing. They were found again during the restoration, but what we know now is that there are trunks at most of the important parts of the structure. On the sole of the tribune, which is above the main arches, you can see them here. It's always the same system, usually 2, sometimes just 1 trunk. And also those on the top here, of which I spoke about already, which were the major discovery. So there are about 50. There's more than 1,000 trump overall in the structures. There's some others in other parts of the cathedral that are now being discovered, but that being the towers, but we don't know yet if they're from restoration or not. So they're about, as you see, this is 30 centimeters, so they're about 50 centimeters long. They weigh about 3 to 4 kilograms, so that's several tons of iron that are placed in the structure of the smaller iron drums are also used. These big columns that I talked to you before, that are really slender, well, they're all attached to the masonry to prevent their collapse, of course, by this kind of iron structure that we discovered thanks to metal detector, and which we can see actually in some places once you have the scaffolding especially in the lens. Also, iron to maintain in place, like in many other churches, the stained glass panels. That's not special to Notre-Dame, but it's also used. And elements in the video tracery, such as iron murals, which might take some from some restorations. That is still under investigation. Also, elements in the framework, which are here probably rather from later consolidations from the modern times, but there's differences that still have to be investigated with iron pegs and bolt rods. Some are forged, some are machined, so it means that they're probably from the 17th, 80s, and also most of them 19th century, which things to learn about the restoration, the repair phases of the framework at that time that can be known about iron. And many nails also that can be linked to several adjustments in the framework and in the pathway that was placed in the 13th century. So all this could be collected thanks and replaced in the structure thanks to the architectural grid that I spoke of before. So iron is not only in the medieval parts, there's also repairs that were installed in the 19th century by Viollet-le-Duc and Lassus, the two architects of Notre-Dame in the mid-19th century. And especially here is the checkered cornice that we saw before, and in which you have some iron drums. And it seems that Viollet-le-Duc did double the reinforcements with a big iron chain that goes through the entire length of the core, and that goes also across. So this one is a bit broken. You can see this one might not be really effective at present, but it's being restored. That goes across both the bolts across the main nave. So many restorations, and also iron for the decorations that were placed in the 19th century. Mainly for lead decorations. When you see lead elements like this, lead is a soft metal, so it does not contain itself if you do not hang it to something harder. And the harder thing is usually iron, such as this crusting here, which you can see here, the structure which was inside. So the lead did melt, but the iron did not melt when fire occurred, because iron melts at a much higher point than fire. And also here, the elements that are used for the decoration of the core that was built in the mid-19th century. And same for the spire here, where you have all these decorative elements. There's an iron structure inside that is attached to the wooden structure of the spire, and that's the elements. Some of them, they could be retrieved after the fire because they fell and they did not. So to sum it up, you can see here that we have so elements in green here that are from the 19th century, or even in red here, the thyroids that are placed on the top, and also the trunks that are here, here, and also here. So you see it's always at specific locations above the arches or on the top of the masonry, and we'll discuss that a little bit. So it means there's not iron everywhere in the construction of Notre-Dame, but at certain specific places. So for the 12th and 13th century, there's actually not much historical sources I can speak. So the monument speaks, but also the material can speak. So that was one of the approaches that we carried out. So on some elements, and I'll speak specifically about the 12 trams that we studied so far, knowing that there's much more to come. There might be, I think, 100 samples that are going to be studied in the next PhD of Maxime Bernard. So that will definitely renew all I'm saying now, but then that's what all I have for now, and I will explain that to you. So we could sample some elements with the architects because they wanted us to do some analysis on them, and others because they were broken, so it was not really a problem, and some had fallen on the books. And so that's why there's not many of them, because it was before the restorations. Now that the restoration took place, all the trams, they were taken down, so many of them were not reused, and we could have access to them then. Most of them were reused, but when there's 1,000 trams, if you reuse 90%, there's still 100 remaining, so that's interesting from scientists. So we had a protocol to analyze this, and I'm going to not to go to everything, but we did some metalographic analysis. I'll speak about this. We also did some radiocarbon dating. I'm supposed to speak about this also, and how it's done, and to analyze some impurities in the metallic matrices that can give some information about the provenance of the material. I won't speak about the tensile tests. And if you want to ask certain questions, I can do that. It's mainly mechanics, and it was done for the architects and to compare with what we had done with other companies. So, second part, to investigate the quality and dating of the ferrous alloys, to study how they were made, and also for the question of reuse for the architects, which was validated because they're reusing the trams in the construction. So we'll try to see what a chemist does when you study iron, you have to cut it. There's no other solution. You have to make a cross section to look inside the matter, because iron is never made at liquid state in the ancient times. So you have heterogeneous materials. So you need to see this heterogeneity. So here you can see this element that we saw before. So it was cross-cut and then in the length. And so you see the form it takes. So we can see when it's been polished, you have a mirror to be able to look at it under the microscope. And it's been etched with special reagents which reveal the structure. So what we can see here is that if we would be homogeneous, we would have a single color, and it's not the case. So we have here ferritic, which is iron, raw iron with no steel inside at all, with no carbon inside, which is in bright. You see the iron grains here, but also we can see that in many samples you have a little bit of steel, which is this brown part, which is mixed here with iron. Not going into the details, but you see it's heterogeneous materials. It's not made of steel. It's not made of pure iron. It's made of something in between, which was actually what came out of the bloomery furnaces when iron was produced. So there's no specific choice of material here. It's the case in Notre-Dame. It's the case in almost every monument we've studied so far, which is about 30 to 40 monuments in Gothic France. So it seems that they use the normal material, not bad quality. I'm not saying it's bad quality. It's normal quality. It's not high quality. They would have made high quality they would have maybe paid it more, but they did not usually require it. And you can see also that there's many impurities inside, which are remnants of the ore, which has not been totally reduced. So we'll speak about this later, but all these points, there are also big weaknesses in the structure. I mean, in the modern steel, you would not see this at all. You have homogeneous structure because the composition is much more controlled. What we can see here also is that we have welding lines, which means that every single, and we found them in every single iron trunk. It's that, so you see them here, I think, quite clearly, and you see that the materials which are assembled, they're not quite the same all the time. Here you have something quite clean, here you have something with many impurities like inclusions, also here. So it means that every trunk was made by assembling smaller pieces of iron together. So that's something that's contrary to what I said before about the quality, we never saw before in any other building. So that's one question, which is still unanswered yet, is why they do that. I try to go further on this when I speak about provenance, but it seems that at one point of the operating chain, whether for cases of reuse of smaller bits, whether for other reasons, they assemble this, and it's not for one trunk, it's for almost any trunk that we study. And knowing that, what I did not say is that one trunk is about 3-4 kilograms, as I said before. That would be the weight, or that is smaller than the weight of an iron plume that would come out of the primary furnace. So there would be technically no need to do this welding in terms of means of production. So that's another question, which is here another constraint that we will have to we're trying to look into. So the good thing when you have steel in your matrix, because it's heterogeneous, is that you have carbon. Steel is an iron-carbon alloy. And about 10 years ago was developed a method that to extract this carbon from the steel to be able to date it using radiocarbon dating. So I'm not going to go in the radiocarbon dating explanation in detail. If you want, we can discuss that later. But it's as if you would date a charcoal or a bone or anything that contains carbon, and the carbon, the quantity of C14, the radiocarbon, depends on the time where the material lived in this living material. So the living material here is wood. It's the wood that made the charcoal that entered the production process of the furnace. You date the production of iron. So here you can see the same thing we made on the carburized part, which you can see here optically. And we had some results for the tribunes, the cranks of the tribunes, and the trunks of the columns. So even though the precision is not really good for carbon dating, especially for this period, we can see that we have really two groups of datings. One for the tribunes, which is the two dates I placed here at the dates of beginning of construction, and here the date of the date framework, as it's known by the chronology. And we see that, well, the tribunes match the beginning of construction, and that the top walls match rather are later than the tribunes and would match the beginning of the 13th century. So here we have now, we're sure that all these crowns, they're really contemporary of the construction time. So that the one of the tribunes are maybe the oldest iron trunks used in the church ever. And so that maybe that it all started in Notre-Dame regarding this use of iron in architecture, regarding flying buttress, regarding going so high for the roads. So all this might go together to try to reach this architectural challenge. So now, what's for the role played by the metalwork? So that's a new thing that is being developed, notably in the PhD of Mathilde, and with a collaboration with the engineers of the structure work group, and that we're doing correctly, is to understand why they place the iron at certain places in the construction, and to try to model the way the construction behaves with the iron and without the iron. And then, so locally and then more globally at the scale of higher parts, bigger part of the movement. And so, as I talked before, iron is not everywhere in the construction. You can see here, it's above the main arches that are peaking at about 11 meters, which were really, really high at that time. And maybe that were not, I mean, when they were built, they were not sustained by the weight of the parts which were not there at the beginning. So that might be one use for these places. But what's interesting and what we're looking at here is on the top, that you see that here was maybe the place of the ancient framework before it was remade in the 13th century in the core. And there is the place of the new framework of the 13th century. And there's questions about how the framework reacts with the wall, the thrust of the framework on this side, and also when you are 30 meters high, the wind that will push the top of the walls. So there's actually modelizations that are being carried out, and it seems that the trunks are quite effective, notably not for the flexion, not that much for the traction, but for the sharing forces that will push the walls aside because of the framework or because of the walls. So that would be one of maybe the goal of these trends and a few of the architects when we go to the last thing I'm going to speak of about the iron is try to understand how the iron arrived on the monument. And then again, we know for the 14th, 16th century, we have reports on tolls that beyond the Seine. We know that there's iron coming from Normandy. We know actually there's also iron going from Paris to Normandy on the other side, so that iron, different maybe qualities of iron cross themselves on the Seine River. We know also that iron is produced almost everywhere in France or in Europe at that time. Iron is one of the most available component on Earth, and that small formations of iron ore they can happen almost everywhere, and they would not be profitable for big industries because they're not big enough. But at the medieval times, some bloomeries, they could settle on some smaller iron ore deposits and exploit them. So there's really iron production in many places at that time. The first approach was on the monument itself, not inside the matter, but to gather information, physical information on the iron trunks. And as you see here on the top walls, they were all dismantled. Because the first row of stone was entirely changed because it suffered too much with the fire. So we could have access, not to all of them, but to most of them, and to see how they were made, and to see what were their shape. And so what we could see is that there were notably different workshops, different smiths that worked on these iron trunks, because they're shaping the trunks in different ways from size. You see here in Nave North, there's a group which is bigger than the other trunks. And when you look at the tip of the trunks here, you have some marks that are made to attach better the trunk in the stone when you pour some. I did not say that they were sealed with lead in the stone, most of these trunks. and so that the iron trumps would better attach the lead when it's being poured to the ceilings that are carved in stone. So you can see there are different forms, and that's something we really did not expect, but you can match some maybe construction phases, but also which are linked here to the intervention of different practices, different workshops which work here, with some places very homogeneous, some places less homogeneous, and so we'll have to look into it more precisely. And then we can go into the matter to have some more information. I already spoke about this slide inclusion, the impurities that are inside the metallic matrix of ancient medieval, ancient iron up to the 19th century. And they really bear some kind of digital print of the ore, because when you reduce the iron ore, you will form these slide inclusions which have basically the same composition. And so if you use a different ore, then you would have slide inclusions with different composition. So there was analysis that were made, experiments, it was like 15 years ago. This is a method that has 15 years last. And then when you make analysis of the same ore, same slide, I'll speak about this later, and slide inclusions, well, you have something which has the same composition, so you have one line. You would have another ore, you would have another line here or another line. Okay, when you get into the analysis of really elements that are really present in smaller quantities in the matrix. So ppm is like 10 ppm is 0.001%, so it's not that much. So you need to have precise means of analysis to get the information. So the first thing we did is that we analyzed these prompts that had some welding lines to see if the welding was between different kinds of materials or not. And that's how it turned out. That here you see the blue area in the middle. We analyzed every dot is one analysis of one slide inclusion, as you can see here. And so the blue dots, they're aligned for this middle part, and the two others, they're aligned with a different alignment, which means that here we have what is called classic weld. It's like you open one bar, you stick a bar in the middle, and then you hammer it. So you have the same bar on top of and bottom, and a different bar inside. And you can also see that there's some add-ins which have a different composition for the flux that was made during this conflict. So still, is that recycling or not? I'll try to go on this question. And then when we mix the information about all the crumbs, the 12 crumbs that we analyzed so far, well, you see that if it would come from a single workshop, you would have just a line. And here you see that you have many, many lines. That means that there are many, many different provenances. So I'm not going to go into the details, but we're using statistical means of analysis because there's many elements to compare to try to have a better representation of the different possibilities of ore sourcing. And what we've come to so far is first something quite interesting, is that we have on what's from the 12th century, apart from one crumb, and what's from the 13th century, seem to be on different really production zones. What's here you have one means of representation, here you have another, they show the same thing, that this is different from that, will be different from the red, and here you have the tribunes and another crumb, and here you have the top coats. So maybe it means that the production means sites have evolved, maybe linked to the differences in the head of the building yard, because in the 12th century you have the bishop, in the 13th rather the chapter. If it would come from their production, it's not that sure. It could be also brought on any market. That's something we have to understand. And what we see also is that often in one front, like the triangles here, it has different provenances. So it means that there's mixes between provenances in a single front. So is that recycling? Is that because, I don't know, the supply in Paris has some regulations that would rather favor smaller elements of iron to come into Paris, and that therefore, because of taxes or something like that, that's questions we're still looking into. But that's something which is really interesting, and maybe it's recycling actually, and that is all pieces of iron that have been joined together, and showing that recycling is not really a problem at that time, whether the use, whether the building yard is rich or not, that's not really a question. So now the question is, and that's we have no results so far because it's Mathilde's work in her PhD, is not to compare the crumbs with one another, but to compare them with real production sites that were known through archaeological remains. And so there's many iron sites around Paris, and even further you cannot see in the Seine and in the Marne, that are the two rivers that go to Paris, to try to link the chemistry of the slag inclusion that we find inside the metallic matrix of Notre-Dame and the chemistry of the iron slag, which is the reject of the production that is found on the archaeological iron production site. So there's a huge campaign of investigation on taking into account former archaeological surveys, archaeological excavations from the past 20 years, maybe, to try to match these iron production site or not with the production which is seen in Paris. So we'll have some results on this question when in a couple of years, but that's one thing we are looking into. So yeah, that's 1 hour. I was done with iron. I don't know if you want me to speak about lead or if we stop here and it's good. I might have 15 minutes on that. Yeah, so it might be too long. I was thinking that maybe or okay. So second metal is lead. So I start with the end of the story. The end of the story is the lead burning in Notre-Dame in 2019. Lead was visible, not like iron, which was not visible, but it's a metal that is not really often looked into. And the fact of the fire, the fact that it caused pollution too, engendered the fact that we had a better interest into this material. I mean, I've been presently working on lead on other monuments for about 10 years, but then Notre-Dame was never a subject of study. And what's complicated with lead compared to iron, when I spoke about reuse and the fact that if you have reuse of iron in ancient times, you always see the marks of reuse inside the matrix, inside the object. Lead, you melt it at 320 degrees, and once it's molten, you can remelt it and recast it and remelt it, and you do not really see the difference. It's slight, but you cannot see it really. And actually, the fact that the roof that burnt was not the first, was not the second, but was actually the third roof of Notre-Dame. And sometimes we know that there's a third lead roof that was made end of the 12th, beginning of the 13th century, after the framework, of course. And that's important because the only donation, the only word we have on construction material by historical sources in the 12th century, in the donation, in his testimony from Bishop Maurice de Sully, is about lead. So it means it's an important material. Only the greatest cathedrals, were covered with lead. It was really prestigious material at that time because it was shiny, because it was a material coming from silver mines, because lead is mainly extracted from silver mines. Lead or silver ore is lead material, so it was produced by powerful people, not really like iron. So first lead roof, total renovation in the 18th century, and even the orientation of the lead sheets was changed from vertical to horizontal. So it was total renovation, of which we know almost nothing. We only know the number of tiles that were cast at that time and their shape. And another renovations 1 century later by the Duc, who added also the presting on the top. So you have different presentations of the roof, and there were also great use of lead in the 19th century for other roofs, new roof in the sacristy, in the newly built sacristy of Notre-Dame, but also the decorations of the spire, and the spire which is totally made of lead. It's lead on wood and also iron armatures, as I speak of. But there's dozens of tons of lead in the spire too. Many uses for decoration in the 19th century. And also in the 13th century, I said that the iron trunks, they were sealed with lead. You can see that how it's done, but also lead was an important material for the stabilization of some structures, especially the slender columns that you see here, all the traceries of the windows, because it's soft lead and it helps thin pieces of stone, which could be fragile, to absorb when the masonry is loaded. Then all the pieces of stone, they do not take the load the same way, and so it helps the stone to take not to break. And that's the lead, as you can see here. The lead is not inside the stone; it has been pushed out because of the pressure of the upper parts of the stone, but the stone did not break. So the questions are the same, but not exactly than for iron, because so I spoke about the uses of lead just before, and to know what quantities were used, I'll just speak about this regarding the question of the roof. But also one important question is the question of supplying of lead. And also to understand better this question of recycling, because as I said just before, not like iron, lead is being constantly recycled. I mean, when you have a lead roof, you need to repair it regularly, and so repairing it means to take down not all the roof, but some sheets of the roof, and to remelt them and to make new sheets, and maybe to make new sheets with new lead, maybe to make new sheets with the old lead. And that's, I mean, we have archives for the 15th century on other cathedrals, and we know that it's same lead which is sometimes reused and sometimes not. And especially with the questions of the big renovations of the 18th and 19th century, for which we have, so 18th century, no archives at all, but the 19th century, we have some archives, but which are not really precise, and sometimes, you know, the difference between archives and archaeological evidence is not always totally the same. And the archaeology does not lie, the archives, they can be not always precise. So to have an approach from the 12th to the 19th century, which was really important. So an approach of the archaeological approach of the remains, 19th and 20th century archives also, so especially counting from the 19th century, also the commercial archives of the lead trade in Europe, in France at that time, the main commercial roads, and also chemical analysis made on this iron lead decrease, elementary and also isotopic, which are the only way to try to go and find source of the material. So we made quite huge number of analysis, and it's contrary to iron, where what I showed you was Notre-Dame. We already had great knowledge on what's going on other monuments because we had a real good background. Here, it's the first time that so many analyses are made on a single monument and that isotopic analyses are made on lead coming from the monument. So it's the first step in a better understanding on all these questions which are related to the use and trade of lead in the Middle Ages to the 19th century. So about the quantities, and I was saying that in the roof, for example, we have some information about the second and the third roof, not much for the first, the medieval one. We imagine it was a bit like the one that Toledo tried to renovate, and that you can have really different means of making your roof with not many sheets but much bigger ones in the 18th century, or with many much more but thinner and smaller ones. But overall, that's about 200 tons of lead which are used for the entire roofing, which is actually quite a lot. It's much more than the quantity of iron which is placed in such a. So we have detail for by counting that we made, and also by some counting that we have about the quantities of lead sheets that were cast at the time of the reunion. And what we know also, I was speaking of reuse, we have some accounting that say that above the roof work, the total roof work, there was apparently 160 tons of old lead that were gathered from the former roof, and that several tons of new lead were also collected to make parts of the roof. So we know at some places that there was some old lead that was used. And there's also the spire inside this. That's why it's a bit more than 170 tons. So we have some partial information thanks to accounting books. And what we try to do is to compare this with what we have in the matter. And one element which can be used to trace the recycling is tin, because tin is an element which is present in soldering. Soldering is made of mixture of lead and tin. Usually it's 1/3, 2/3. It can be a bit different, half, something like this. But so soldering was used, and could be when you recycle your lead, you would not take the soldering out, and you would mix the soldering with the lead, and then your content of tin in the recycled lead increases. So in a new lead, you have no tin at all. And when you start to have some tin, it can mean that it's been some recycling. And what we see here is for all the upper parts, the spire, but a bit less the spire, but mainly sacristy roof, and mainly the main roof actually, that there are about, that's 4,000 ppm, is 0.4% of tin, which is much more than nothing. In comparison with a gutter from the 20th century, which is new lead here, which has almost nothing. So that's an important, that's one clue that shows that probably here what the archives say is true about recycling of lead in the structure. Here I give some prices which show you that at that time it was profitable to get some old lead, even if it was old lead coming from another monument. It was much cheaper than illegal. And if we look at the medieval lead, that was 19th century lead, we see that the picture is a little bit different. That we have sometimes great variation in tin, up to 10% of tin in one single lead, but most of them, they're much lower in tin. You have here the bar here is the the average. So it means that most of them are below, but some of them are really high. So it means that probably in the 19th century, recycling was predominant, but that here in the medieval times, you have several supply from recycling, but also not for recycling. And when you compare, not going into the details, but other elements with other elements such as antimony, which is also present in lead, you see that when you have even on a single for a single batch of lead, you can have really different compositions, meaning that you have different provenances, different sources that are easily being mixed in this spectrum. Just ending with so this first isotopic analysis that we did. So I'm trying to explain this graph, which might not speak to you for the present. What's important in isotopic analysis to gather the different sources is to try to link them with a line, because the ore sources they can be rather concentrated or fewer concentrated, but if you link things with a line, it means it should come from the same source. And here you can see that some of the sources are clearly distinguishable. The lead gutters of the 20th century, as I spoke of before, it's clearly aligned, it's clearly different from the rest. So this is new lead from a single mine, which is not being mixed with something else, apparently. Here, restored cresting for the 20th century, also the blue ones, here the light blue ones, has clearly different line, very different comments. Spire ornaments also, which are here in green, not all of them, but some of them, there are truly different lines here, meaning that in the 19th century for the spire, there should be some new lead that is provided from somewhere. And that most of the lead in the middle here are grouped in something which cannot really be called by line, but rather a group. And that's the medieval ceiling, and that's the main roof lead sheets we spoke about. So we try to detail this. That's a highlight on this box, showing that even though they're close, the roof lead sheets and the medieval ceiling, they seem different. Which means that, to me, that the first lead roof was cast in the 13th century, probably with the same sources of lead than the medieval ceilings, which did not move, which are really truly from the 13th century. So if here we have something different, it means that something in between, there's been a new source of lead. And that's to me probably the 18th century that the renovation might have taken the medieval lead out and replaced by another lead. If we agree that in the 19th century, most of the lead was reused in the new construction by the. So it means that we have information, I think, here about the restoration of the 18th century that erased the medieval signal of the lead, at least partially, or I think totally. And then, if we look at the 19th century here, lead, the medieval ceiling is not here anymore, it should be here. You have the main roof, which has the same color. You have the spire ornaments here. And we can see that we have clearly two different lines. This one is the line of, I spoke of before, the new lead for the spire ornaments, which also seems to appear for part of the sacristy roof. And the other one is the lead for, which is being probably recycled from the 18th century for the main roof, and which is also a bit for the sacristy roof. It means for the sacristy roof, which confirms what some of the archives say, that we have two different sources. We have new lead, but also lead which matches the recycling, which was that of the main roof. And this new lead here from the spire, well, it might come from Spain, maybe from Cartagena, or from the sources from La Carolina, from which we have exports since the 1860s. So that's what the commercial road of lead says at that time. So you see here, it's on the same line. Here we have La Carolina is here, Cartagena is here. So it's really on the same line that our green lead here. Rio Tinto is on the other hand on a different line, so it might not come from there. So it might come directly from Spain before the 60s, and maybe through England, because at one point Spanish lead comes to England and then it's exported from England to France. So when it arrives here, it's English lead, but it's English lead from Spain. So here we have evidence regarding the archives, regarding some of the analysis, probably that we have this lead road that arrives to Notre-Dame, but also with a good share of recycling, as I spoke of before. So that's what I wanted to talk to you about on these researches on iron and lead. As you understood, it's continuing, because here for the lead, now we have to compare Notre-Dame with other monuments from the medieval times, from the 19th century, to see if the patterns are the same, or if the patterns are different regarding the commissioners, regarding the architects, the Parisian building yard or not. And for the iron, you see this PhD which is coming and which will give much more information, especially on iron supply for great building yards located in Paris, might have also such a Parisian with the Saint-Chapelle, with the Belgian of Vincennes, before, but never looked for the questions of provenance. And I would like to thank you for your attention, and to thank you for, and thank also all these people, because as I said, it's not a single work, and it was also allowed by many people, by the architects, by the regional archaeological services, historical monuments, and also the contractors that are on site and with which we exchange a lot, and which help us during the collection of the trends, because we try to be on the field as much as possible. We cannot be in Notre-Dame every day. We have to so that's what to thank all these people from the science group to the restoration yard, because without them it would not have been possible. Thanks a lot.
Thank you very much. For this excellent presentation of the festival of what you know, all the things made in Naples. I don't know if there is any questions in the audience. They are to the room, some questions.
I have two questions. One derives from your paper in the still, but perhaps you would like to answer afterwards. It's about you look at green wood rather than dry wood, which was mentioned some concept. Here I have a general question. I'm not sure if it's too fair to ask, but construction techniques and the development of technological solutions seems extremely perfection. Were they as they went solutions, or were they thinking about solutions, or does this come in a tradition of building big monumental structure that has its gone by somewhere in the past?
But
because the use of iron and the use of lead, extra what you say, and also the other stuff, and the combination of the walls and the strength. It's walls seems to come from consolidated knowledge on how to do this.
So I think there's many things. Sorry. So there's, I mean, these great building yards, they were experimenting, definitely. New things, new solutions, trying to go thinner, go higher. Sometimes it's too high, it broke, sometimes not. And then they also had, I mean, making a lead out of lead roof is not something new. I mean, there were lead roofs. We know that the Abbey of Saint-Denis, for example, was a roof that was given by the Frankish mines of Mel, that there was already trade, and that's led this material into power, so it has something to do also with that. And about iron, which strikes me on the first buildings that use iron, such as Notre-Dame de Paris, such as Chartres, for example, is that they use ancient techniques. But they adapt them. I mean, using iron crops in the masonry is not new. It's been known since ancient times. It's used in ancient temples, Greek temples. Colosseum in Rome might be one of the monuments using the most iron ever. But what happens in those monuments is that it's not at all the same kind of structure. It's much thicker, and you need stability from the ground. You don't need stability from the ground. So there's something to be really, really flat. So to be able to go a bit higher in these temples, you have no mortar. So it's really different, and the crowns they're used at the bottom for the first rows of stone. 1, 2, 3, maybe a bit more. As you see here in Notre-Dame, it's always on the top. So that's the new use. But it's an ancient form having a new use. So maybe there's also this kind of, in the thinking, it's inventing something without inventing something. Using some old to make some new, and I think in the medieval way of thinking, this could also mean something. But after the 13th century, they innovate some more because they make some chains, they make some pirates, and there you have a new form. Really medieval one, which is they're invented and they be more efficient because you have something continuous and not stone, iron, which is. Yeah.
33 meters high.
Yeah.
It's a challenge for.
And then Notre-Dame is really a particular monument. It's maybe much slender than many other. It was one of the highest if you compare to Chartres. It's great monument, but it's thick. It's really thick. So it does not work the same. And you can see that it was some experimentations. We don't have the archives of if they do something at one time. I mean, we know for the greatest constructions, such as Beauvais, that once you reach a point, then it falls down because you have not calculated it properly, and then you can still consolidate it, but then so that's part of this and part of that. But it's true that taking an interest into these great construction sites, you need something particular. It's not a small church. It's not a random construction. It's some place where people invent and new ways of building, the new ways of working materials, use of new materials, and it takes time also because between there's generations of builders between the 1160s and the beginning of the 13th century. Generations maybe, so it also takes some time. I will speak about it.
Hi. Yeah. Can you hear me? Can you hear me?
Well. Wow.
Thank you so much to Professor L'Héritier for this very interesting presentation. Your work with the metals group in Notre-Dame is well known in our college. Indeed, last summer, I encouraged my master's students to read your paper, your collective article entitled The First Iron Lady, which was published at the beginning of this year. And so this is a very good opportunity to know firsthand your work at our college. So I thank you so much for the presentation. And I have one question, and perhaps I beg your pardon if I missed some of the details or information you were providing throughout your speech, because sometimes the sound was not the best one. So perhaps I missed some data. But my question regards the last part of your presentation concerning the metal supply of the building yard, and the question is about the uses of the past, and it's a double question. So on the one hand, I would like to know, I'm very much interested on the iron cramps, and so I would like to know if by chance iron cramps are the result of a medieval reuse. So we know that in ancient and medieval times, metals, and especially silver, for instance, or gold, were melted once and again. For instance, coins were melted several times and were used to produce new artifacts or objects. In the case of the Notre-Dame iron cramps, the medieval ones, are any of them the result of a medieval reuse? And the second question regards the uses of the past, that concerning the 19th century on medieval times. So did Violet reuse medieval metals, but especially the iron cramps, because you were talking about the remelting of tons of lead in 19th century, but what about the iron cramps?
So, if I understood the question correctly, for the medieval cramps at the medieval times, so I'm not sure it's reuse what we are looking at, but that's one option. But if it's reuse, it's indeed reuse from medieval medieval iron. It's not a reuse for a long period of time. But we're not really sure about this. But that's one option. If it would be reused from a much former time, then when we date the iron, we have the date of the production of the iron, not of its use. So here we have dates which really match the construction, so it means that it would not be a reuse over a long period of time. And in the 19th century, don't think Viollet-le-Duc, he let the cramps in place in the checkered corners. He did not, he basically he changed some stones, so he took them out in part. We don't know if we replaced them, but there's still some of them in the masonry. So he did not take, because we could see them during the restoration. But it was really inside, so we could not really access them like the cramps on the top walls, which were all dismantled. So we did not have a greater look at this one. So whether he reused them, whether he let them in place, I'm not really sure. But what's interesting is that the architects now, they're reusing the medieval cramps in the construction. So, and it's really funny because, because on the top part of Notre-Dame, the framework is going to be new, because it's new that is going to be used. The stones, the last row of stones are going to be new because they're changed, and the iron cramps are going to be the only original thing on the top of Notre-Dame so far. And some of them, there's actually one contractor who replaces them, one of the two contractors, at the exact place where they were, between the same two stones with the same 1 centimeter precisely. And sometimes we're using the old lead too. So there's, if you're into this thinking, this philosophy of reuse, how it's being done now, that's one thing we work with the anthropologists, which are really interested in these questions. And so that's a group we really like to work with. And so it's really interesting to work on this and to see how it's done now, to compare it to how it was done before, and to have this overview of several centuries about this questions which are fundamental now when we speak of recycling, reuse, something that speaks to us now, but it spoke to people in the past too.
So regarding the medieval times, so there is the possibility of iron cramps being the result of a reuse.
I think with the PhD that is going to be made, we'll know much more about this now.
Thank you so much.
Love yours.